Good morning, dear children. In the previous class, we have learnt about the measurement of length. We have also learnt about the various measuring devices that are used to measure the length. Now, let us move on to the measurement of mass. Now, before we move on to the measurement of mass, it is important that we first understand what is the meaning of mass. Now, if I tell you which one of the two will feel heavier, I have a jug of water and over here I have a glass of water. Obviously, the jug of water is heavier, whereas the glass of water feels lighter. Why is it so? It is because in the jug of water, the quantity of water is more, whereas in the glass of water, the quantity of water is less. Or, in other words, you can say that in the jug, the quantity of matter is more, and in the glass, the quantity of matter is less. So, we can say that the mass of the jug of water is more as compared to the mass of the glass. So, why is it so? It is because of the matter that is contained in it. So, mass is nothing but the quantity, or you can say the amount of matter that is contained in an object is called as the mass. Now let us see the units of mass. The standard unit of mass is kilograms. It is expressed as kg. Smaller units of mass are gram and milligram. So, dear children, we already know the units of mass. We have been studying about the units of mass since class 3. So, you already know that milligrams, grams, and kilograms are the units of mass. So, if you have ever been to a grocery shop, or maybe if you have visited a vegetable seller, you have seen them measuring the vegetables, or if you have been to a shop, then they have measured the rice or maybe some other items with the help of standard units, right? So the standard unit of mass is kilograms. Now, if you want to measure smaller units, then grams and milligrams are used. Now, let us see the relationship between 1 kg and grams. So, 1 kilogram is equal to 1000 grams. 1 kg is equal to 1000 grams. Now, 1 gram is equal to 1000 milligrams. These are the relationships between the units. So, in the previous slides, we have already seen what mass is. So, what is mass, my dear children? Mass is the quantity of matter contained in a body, or you can say how much matter is there in an object. That would be called as the mass. So, mass is nothing but the amount of matter that is contained in the object. Just like we had the example of glass of water and a jug of water. So, out of the two, which has more matter in it? The jug has more matter because it has more quantity of water in it, right? So, the mass is nothing but the quantity of matter that is contained in it, that is there in it. So, we already know the smaller units of mass. The smaller units of mass are grams and milligrams. So, these are the smaller units of mass. Now, the standard units of mass you already know, kilogram. Now, suppose if you want to buy, like for measuring larger quantity of mass, larger units are used, such as quintal and ton. When you buy large quantities of coal, or maybe when you buy large quantities of rice or wheat, then In such a case, the quantities are measured in the units such as quintal or ton. If you have ever noticed, then the merchants, the coal merchants, or maybe the rice merchants or the wheat merchants, when they do their business or when they sell the rice, coal, maybe, so in such cases, the give and take is conducted in such a way that they are merchants, right? So they will be selling off huge quantities of rice and huge quantities of coal. So in such a case, small units cannot be used. So in such a case, larger units such as quintals and tons are used. So 1 quintal is equal to 100 kg. All right. So if you are going to measure 100 kg, you are basically measuring how much? 1 quintal. You might have heard these words before. If there is a wedding in your house, if you have ever seen, then during the arrangements we usually buy rice or maybe wheat in quintals. Then we have 1 ton. Now ton is another bigger unit than quintal, so 1 ton is equal to 10 quintals. So it is a very huge quantity of mass, right? So it is a huge unit of mass. Now, dear children, there are some measuring devices that are used to measure the mass. If you have ever been to a vegetable seller, you might have seen that he measures the vegetables like tomatoes or maybe any other vegetable that you have using a measuring beam, right? Measuring beam balance. If you have ever seen, then what did you notice? On one side, what is used? On one side, the vendor, he puts the vegetable, and on the other side, what does he do? He puts the standard weights. So that is how the measurement is done, that is how the comparison is done. So mass is measured using a balance, right? So mass is measured using what? It is measured using a balance. Now the unknown mass of the body is compared. Let us see how it is compared. Now for example, let's take over here. If you have ever been to a vegetable seller, you might have noticed. What did you notice when you went to him? That he uses an instrument like this. He uses a device which is of this type, which is in front of you. You can see right now. So this type of a instrument or this type of a device is used by him to measure the mass, right? So on one pan, what does he do? He puts the tomatoes or the vegetables he puts, right? Now this is the unknown mass. This is the unknown mass. We're still trying to find it. And on the other side, he puts what? He puts the standard weights, right? Now this is the construction of a beam balance. This is how a beam balance looks like. So you can see in the center over there is a rod, that is the beam, right? Then two scale pans are attached. Now these pans are of equal weight and they are fixed at equal distances. Now this is very important. For your beam balance to measure correctly, it is important that the beam balance pans should measure equal in weight. That means they must be of equal weight. At the same time, they must be placed at equal distances. Then on top you have the pointer which helps us in measuring, right? Now let us see how the beam balance is used for measurement. These were the parts. This is the construction of the beam balance. These are the parts of the beam balance. Now let us see how basically the beam balance is used. Now over here, this is a beam balance, correct? On one side you have the unknown mass. Now this is the unknown mass. This is the mass that you have to find out. You have to find out what is the mass of these tomatoes. On the other side, you have the standard mass. So on one side, you have the unknown mass, whose mass you're still trying to find, and on the other side, you have the standard mass. Now, standard mass are mass that have proper units like 1 kilogram, 2 kilogram, 500 grams. What are those? Those are fixed units. So that is fixed, or you can say standard mass. So you compare these two masses, and then accordingly, if the pointer, now the pointer is there, correct, you have seen in the previous diagram on the beam balance, which helps us to determine whether the masses are balanced or no. Now dear children, the beam balance can be of different types. The beam balance used by the vegetable seller is of different kind. Now suppose if you want to measure costly substances like gold, silver, then a physical balance is used in the laboratory. Okay, so the physical balance, this is the physical balance. It is used in the laboratory, and the physical balance is very sensitive. That means it is used to find accurate measurements, because it is used to measure costly substances like gold, silver, etc. Now this is the physical balance, and you can find a physical balance easily in a physics laboratory. It is used in order to get accurate or precise measurement. Now let us see the construction of the physical balance. Now you can see this is the beam. On top, the area marked with the help of the pointer, or you can say the area marked with the help of the arrow, indicates the beam. So it consists of a light and rigid beam of brass. Then over here you have the wooden board. Now the wooden board is basically giving the support. Now in the center you have the metallic pillar. Then can you see, these are the pans. You have one pan on the left and the other pan on the right hand side. Now look carefully. This is how the beam balance looks like. If you see, in the center there is a white thin rod, a thin line basically, which is there. Now this is your pointer. The pointer moves left and right. It moves on left and right. It swings on both the sides, right and left. When it swings equally on both the sides, then we can say that the physical balance is working properly, or we can say that the masses are balanced. Then if you can see properly over here in the center, you have the ivory scale. Now there is a scale which is present. It has markings from 0 to 20. Now these markings are used to take the readings. Now I have a demonstration over here. You kindly see it properly. Now this is your physical balance. Let's take a closer look at this. This is your physical balance. Now if you see carefully on top, then what can you see? It was the beam. Okay, on top this part is the beam. Then you can see this rod attached down. In the center you have your pointer. Then these are the two pans which you can see. The pans are attached with the help of a hook over here. Then below you can see the scale. Now suppose if you want to measure the mass of this object which is kept over here. Then you keep it on one pan, and these are the standard weights. Now standard weights can be kept so that you can measure the mass of the unknown object. Now this is the unknown mass that you're trying to find of this battery, right? And these over here at down you have the standard masses over here. So that is how you will measure. Now one thing that you have to remember over here, if you can see properly in the figure, then there is a pointer and you also have a scale over here, correct? Now if the masses are balanced, then what happens is, in the beginning only, if you want to find out the mass of the object, so in a beam balance you need to first calculate the resting point of the pointer. You have to find out the resting point, and before that you have to find out the zero resting point. So in order to find out the resting point, you have to put equal masses on both the sides if it is properly balanced. Like if you put the weights and if it is properly balanced, then what will happen, the pointer will start swinging left and right. So when it starts swinging left and right, you can calculate the you can calculate the resting point of the pointer. Then in the beginning only you have to calculate the zero resting point, and then if the zero resting point and the resting point coincides, that means you have found out the correct mass of the body.